Alright, so let us, as I already told you that today we are going to finish off with the syllabus. So just to show you the module 7, the important parts of module 7 which you are supposed to follow, I'll just go briefly on the topics on hand, and I'll show you the syllabus also, that what are there in module 7, and I'll focus on specific areas where you should also focus primarily during a term and exam. Because it's a vast topic and it's a kind of vague as far as the syllabus is concerned. So there is no specific set of elements that we need to understand, because there are a lot of things under the network security, to be honest. But ideally, these are the topics which are there as given in one word, I would say, in the syllabus. So that's why these are the 5 topics which we mostly will follow. In that, particularly web security, software security, and IoT threat, this will all come in as like short notes, most probably. So that will come at the end of this presentation. The transport level security, or the SSL, is what a little bit different compared to. I think it requires a little bit of understanding. So maybe I'll focus on that area first. Firewall, as you all know, might be the process involved with it, but still that also I'll be involving with this. This whole presentation, what is there from this part to the end, is already uploaded in your course page. Alright, and that will be sufficient for your module 7 itself. Later on Wednesday, when we come back for the quiz, I'll let you know about the content or the process to go about discussing the term and preparations and all those stuff. Right? So, to start off with, these are the 5 elements that we come across, and we are somewhere over in the application layer and beyond that. This is 7-layer OSI model. Hopefully, I don't know how many of you know it or not. This is how usually a network is divided. Okay, this is the open system interconnection model, we call it, the 7 layers. Please remember this, because this will be useful for computer networks, for our wireless communication for that matter, for cryptography and all. These all are different parts where every other element of the hardware and the software work. If you observe carefully, the hardware layers is where we are looking at the bottom 3, whereas the top half 3 is the software layers. So both software and hardware are required. Rather, if you observe this hardware, the physical layer, the data link layer, this is where the device will come in. And that's why you can see the network layer is also there. The router, the switches and all, those come under that part. Alright. And the portion that we are going to focus mostly is the software part, that is application layer and beyond that. So the application to presentation layer, you can say somewhere over here we are lying for the cryptographic solution. Alright. So let's see about that. So transport level security is provided an end-to-end security service. I can see over there itself. So it's a process in which we are providing the security to each and every layer. Because remember, as of now, what we know that we need an encryption for the data. We also know about the cryptographic hash function. We also know about the digital signature. We know about something called as MAC as well. So all these things need to be encapsulated and authenticated by some means. Apart from that, there are certain degrees of security that is to be provided in order to make it secure. So that this whole process, the 7 module, deals with the different sets of security aspects that can be taken care of while sending the data from client to server. You will soon find in most of our discussion over here, we are going to discuss it in terms of client and server. Now, the Alice and Bob which was there is now converted to client and server, because this is primarily the networks, how it will behave. So we are going to talk about the technical terms of client and server for that matter. So secure socket layer, this is a very important topic for you. So please make a note of it. Secure socket layer. TLS will do it a bit, but that is not that important, because TLS works as the SSL works. So mostly we'll focus on SSL. Now, what is exactly SSL? For that, we can understand from the diagram. As I said, we are just below the application layer somewhere. So SSL or TLS are going to be used. So let's see how about going forward. So this is called a secure socket layer. Okay. So let's see what it exactly does. So usually what happens is, whenever the data comes in from the application layer, it undergoes this many separate applications, or like the divisions of it. The data goes through the fragmentations. You can see the terms, they are very much common. We have already used at some point or the other. Fragmentation, compression, message integrity, confidentiality, and framing. All these terms have been used in some way or the other in our algorithms that we have defined. Okay. So this is, remember, you can see, for example, message integrity. If you say, we have already discussed that in cryptographic hash function, what is integrity. So you can see SSL uses a keyed hash function to create a MAC to preserve the integrity of the data. So already we have discussed about MAC, we have already discussed about the hash function. So it is basically the application of those and how it is to be done in a network. That's the protocol that is followed globally. So that is the briefing of this whole topic. Alright. So these are some of the designated work that it does. But again, to do that, there is some standard procedures. So the standard procedures are, first of all, the key exchange algorithm. Already we have discussed about the DH algorithm, L-Gamma process itself. That same thing is given over here. But now in terms of the technical terms, so you can observe here, usually to exchange an authenticated and confidential message, the client and the server will require 6 set of information. Okay, 4 keys will require and 2 initial vectors we will require. Why 2 initial vectors? Because 1 we will require in the server end, 1 you will require at the client side. Okay, client is the transmitter, server is the receiver. In that way, if you imagine it that way. And the 4 keys in between, there is an encryption key, there is an exchange key, there is a master key, we will see that, and there is a key hash function or the HMAC that we come across. So all those things come under the 4 keys here. Alright, so these are the basic requirement of 6 keys which are there. Now usually, as you can see, SSL defines 6 key exchange method. Many of them already we know about the technique, and the same thing is repeated over here as well. You can see the RSA, our very common RSA. You can observe the DH, the Diffie-Hellman key exchange technique again. Except that now with standards, there are certain changes, but the rules and the process are the same. So we are not going to invest much on the time on how the DH works over here, as we had already discussed in module number 5. And that is sufficient for you. It is just the protocol, what it uses as in terms of the technical name. So you can see the names are a bit different, nothing else. So you can see anonymous Diffie-Hellman. Then we have ephemeral Diffie-Hellman. Then there is a fixed Diffie-Hellman. No need to discuss about the details of it. It's just that the same procedure, except in one case, maybe the key size will be more. In one case, the private key will be known to both client and server. Like that, very specific changes are there. Apart from that, nothing much. Key exchange protocol is the same. Okay, it's just that you don't need an in-between server like the KDS, KDC, you don't need that. Same thing is available. So that's why we are not going to focus much. It's just that we will just need that one line of it. That, for example, null. You see the first one, null is there. The key, there is no key exchange in this method. No pre-master secret is established between the client and the server. It's a very like an easy trap for anyone. Any intruder can come in and see the data. So this is basically not used as much because the client and the server doesn't even know about the pre-master secret. Pre-master secret is something like an initial vector or the initial key. Okay, not the encryption or the cipher key and all those things. It's just the key to identify the client and the server. Now, if that is also known, it's not known between the client and the server, how will they make a connection itself? So that's why it is not being used, and naturally, one of the common techniques is RSA. As we all know about the RSA technique, how it is being used. We know the process of it, right? The primitive roots and all those processes. So same thing over here. You can see the key, one of the key factor is the server needs to send an RSA, and RSA, the encryption decryption certificate. That means the server needs to identify itself or broadcast the message that yes, I am the intended server. You can connect to it, and that it will do using a particular certificate. Okay, that also is the standard is there. If please go through the previous day's lecture, I will find the certification, how it is to be done and all. It's just a theoretical understanding. So every server will have, in fact, every client will also require some kind of a certification. Okay, then like from the certificate, it will identify that yes, it is the correct server. Just like suppose we have given an exam and suppose or you are graduating from VIT. Now you will have a certificate to prove that you have done your BTech from VIT. And that certificate is alone for everyone to identify that you have done a BTech. They are not going to see that what you have done in 3rd year, 2nd year, 4th year, whether you have passed or not. Same thing. So the certificate will be issued from the server end, which will be identified by the client, and based on that, the connections or the sessions will be established. So same way, you can just look into it. I'm just skipping a bit on this because this is not that detailing is required. So every protocol will have certain like certain parameters. Please go through them. Okay, so this is just a one line I have mentioned it on the algorithm. You don't need the details of it. But all of these are like for the key exchange. The basic rule is the key exchange part. I'll come to the interesting part of it where it becomes more technical. Then we have the encryption and decryption algorithm. Here also, if you observe some of the cases, the stream cipher, the block cipher, the DES, I guess all of you have can identify some of the terms which are used. So you can see block DES, okay, streams RC4. Fraudzilla is a new technique which is not there in our syllabus, so we are not going to focus on. So these are some of the encryption techniques which are usually adopted by SSL. Remember, this is not the encryption we are talking about. It is just the process of taking the data from the application layer to the next layer. So for that, the concerning encapsulation is done by SSL. So that's why, in fact, this is the reason why we can write HTTPS if you know it for sure. So that's the logic behind it. Hash algorithms which usually are primarily used are MD5 and SH1. MD4 we have done in class, as I told you, MD5 is an extension to it. SHA 512 actually we have done all the way back for cryptographic hash function. They use the preliminary, the discussion at least for the time being is SHA 1, the first generation of SHA. But we have done SHA 512 as well. But again, the principle is the same. The logic is the same. Now in case of, you can see over there, so it's 160-bit SHA that we have done. We have done 512-bit SHA. Okay, so that's the difference. So please go through it. As the term it indicates, only one or two lines is sufficient. As you know the process of hashing, what is the need of it? So the same thing is mentioned over here. This is interesting what I feel. This is called a Cipher Suite. Okay. This is how actually the signatures of the exchange key as well as the encryption keys are established in a network. And this is actually the way it is written. Now, if you observe, I have mentioned the details of it. So, SSL is the protocol that we use. If you observe HARSA, it's mentioned over here. So, it is basically meaning that ephemeral Diffie-Hellman key exchange with RSA digital signature. So, that is indicated over here. Alright, so the digital signature type is also mentioned because this information needs to be known both at the server end as well as server should acknowledge it back. Remember the process of key exchange and the session key exchange. So this is where the exchange will happen. This all information will be shared one after the other. So and the with part is basically a conjunction. Okay, so you can see with separates the key exchange algorithm. So this is this part, if you observe, this is the encryption algorithm and the SHA is acting as the hash algorithm. So if you remember, if you observe here, the three basic needs that you have, one is the encryption algorithm, one is the hash part, okay, and the third one is called as the key exchange protocol. So these are the three things. So that's why if you observe in most of the cases, it's mentioned over here actually, key exchange, hash and encryption. Each of them will require 4 such key along with 2 such initial vectors. So both at the client side as well as in the server side, we will require 6 set of initial vectors or like keys for that matter. So this is how it is being used. Okay. Similarly, these are some of the structure of it. You can see over here, same thing. SSL is a signature and each of the cases it will change according to what we are going to use. So this is just an example for it, how the Cipher Suite works. Now, in case of the cryptographic parameter generation, you can see again it's mentioned over here, 4 keys and 2 initial vectors we require. Okay, and as you know, in most of the algorithms we have come across, we have found that the initial vectors are required initially to generate the next set of keys. In most of the algorithms that we have discussed. So those are the initial vectors we are talking about. And keeping that in mind, let's discuss about now suppose we have all this information. Now we have to have the server and the client to connect among themselves. So for that, there is 2 terms associated with it. One is called session, the other one is called connections. So in session, in general, what happens is, you can see, after a session is established, the 2 parties have common information of session identifier, the certificate of authenticating each of them. As I said, there will be a certificate exchange based on which there will be a authentication that will be made at both sides. The compression method being used, that is the hashing that is being used, because remember hashing will always generate a fixed set of data set. And then we have the Cipher Suite. How the Cipher Suite is developed, I told you the diagram, the initialization. and a master key that is used to create the key for the message authentication center. So that is these are the information that is supposed to be shared whenever a session starts to happen. So we have this, all our information are being mentioned over here. Okay. So the two entities to exchange the data, the establishment of the session is necessary but not sufficient. Okay. And so you can see two entities exchange two random numbers and create using the master key the elements that is there. You can see it for yourself. The last line is highlighted because the separation of a session from a connection prevents the high cost of creating a master secret. Okay, so every time the session is established, suppose there is no such connection, you can see a connection between two parties can be terminated and re-established within the same session. As we all know for the internet and all how we use it, so that session is initiated in that way. And when a connection is terminated, the two parties can also terminate the session, but it is not mandatory. Okay, and that's why the separation of a session and a connection prevents the high cost of creating a master key. For every session, the generation of master key is required. Okay, so that's what is mentioned over here. And these are the information that is usually done for a session. So please look at it. It's again, these are the certificate type. This is a standard certificate type X509. Okay. And Cipher Suite, Master Secret. This is all being shared. Okay. As I said, this is very monotonous in a way. I'm just keeping for the time being. So you can see this is already, I told you, the client and the server have 6 different cryptographic secrets, 3 read secret and 3 write secret. Okay. So 3 read means it is reading from the what is being sent to it. So if suppose I'm considering it to be a client is reading the 3 secrets from the server before authenticating it. Same goes with the server, as well as it is also writing its own encryption. It's sharing the exchange key as well as the encryption key. So hash function, exchange key and the cryptographic key. So that's what is mentioned. Now after that, how SSL does it? So these are the process. Now SSL usually will use certain elements to authenticate this data. And to authenticate that, we usually have handshake protocol, very important. Please make a note of it. Like I told you, the SSL part. So handshake protocol is looking something like this. This is how it looks at. So you see, this is where the app is. And SSL works somewhere in between the app. Now, the process, the requirement is what we are putting in. The exchange, the master secret, the cipher text. Now, if you observe over here, the process that it does is something called as handshaking protocol. Then we have a chain cipher spec protocol and the alert protocol. These 3 protocols will go into something called as record protocol, where the application layer data will directly come in. So you can imagine a scenario where the application layer has a data. It will send the data directly. The SSL part is authenticating the server to the client based on the requisite technique. Based on that, whatever is recorded as the final, that is sent to the next. Alright, so that is basically the process. Now for handshaking, you can see from the term itself, what it means is that it is taking the information from application layer and it's authenticating it with all the necessary requirements, like the keys are properly exchanged or not, certificates are properly exchanged or not, whether the hash functions have been included or not, encryption keys are there or not, whether the data is encapsulated or not, like that, so on and so forth, those information, it will go on checking. So you can see from the very details of handshaking, 4 type of session or four phases of handshaking that goes in. First, establishing the secure capabilities between the client and the server. Second one, server authentication and key exchange. The client should know about the server. And third part, client authentication and key exchange. Client also should send the information for the authentication that yes, I am the intended user. As I told you with the example of mobile communication also, when we are trying to call someone, I also need to authenticate myself to the server. Server here for mobile is BTS, the base stations. Alright, so you can imagine in that way. So in that way, the BTS should know that I am calling where I am an authenticated user. I am using a device which is also authenticated. I guess all of you know that when we are using a mobile phone, we also have an IMSI, and that IMSI should be, or the IMSI we call it, and the IMSI should be unique per user. You cannot have 2 IMSI of the same, you can have 2 devices, but 2 SIM will have 2 different IMSI, right? So that's how it is. So in that way, what happens is that the user is authenticated to a particular network. So the same thing is done over here. The client, I'm the client. The server is basically Airtel or the Reliance or Jio, whatever it is. They are the server. So the authentication of handshake will take place. But naturally, it takes very small time to do all this process. Naturally. So that's why we don't realize that much that this is happening. So this is about the 4 phases of client. So I'll just brief you on this. So you can see that after phase 1, the client and the server knows the following: the version of SSL, the algorithm of key exchange, the compression method, the random keys about the information. After it is done, the server is authenticated to the client. Server is authenticated to the client. The client knows the public key of the server if required. Okay, so that's for phase 2. Third phase is now client is sharing the information. Client is authenticated to the server. Both client and server now knows each other. So now they are ready to make a connection. So now after phase 4, the client and the server are ready to exchange the data. Whenever it is asked, you just simply explain it one by points like this. It will be enough. This is again the same, the cipher spec that we have discussed a little while back. Those are checked over here, that whether the DES is correct, the hash function is correct, whether they are properly maintained or not. So that checking is done over here. Also, alert protocol is there, because there are 3. You can see, observe that there are 3 such things. One is handshake protocol we have observed. Change cipher spec protocol. If at all any changes are required, that information is shared only with respect to the exchange keys and all. And then we have the alert protocol. Alert protocol is basically creating an exception or giving us some warning. You can see this meaning of it, this part. Sender will not be able to send any more messages. So there is some index is given. So based on that index, so batch certificate 42 received the certificate which is corrupted. Okay, so the certificate expired. That means the server or the client is showing some information which is not matching to the database. If I am not an authenticated user, but I am trying to make a call, or I'm trying to establish a call, then definitely that will throw an exception. So alert protocol is for that purpose. So altogether, if you consider all these 3 protocol, that goes to record protocol. Because you can see in record protocol, what happens? It carries message from the upper layer. Alright, the message is fragmented and optionally compressed. A MAC is added to the compressed message using the hash file algorithm. Alright, so the message coming from the application layer plus the handshaking, the cipher and the alert protocol, whatever the information, that goes to record. And that information is shared in the next. Okay, so that's how the protocol works. As I said, TLS, so this part of SSL up to this record protocol, please go through it a little bit, especially the architecture of it, the designated elements which are there for SSL, as well as the handshaking technique, which are like as I described over there. That is enough. So please make a note of it. Now we come to the next part, which is TLS. As I said, TLS we are not going to invest much because this is the upgradation of SSL. Nothing much as such in terms of technical aspect, to be honest. You can see the discussion topic, they are all the same. They are all the same. So Cipher Suite, alert protocol, handshaking protocol, they are absolutely the same. Nothing much. Okay, just very difference is that you can see SSL version 3 is comparable to TLS version 1. Okay, certain changes are there. For example, see the signature, the Cipher Suite we call it, is now changed to TLS. You can see the first line, it was SSL in the previous case, it's now TLS. But most of the things are almost same. MD5 is used, SHA is used. So you can see this is 128 SHA. Instead of SHA 1, now I can use 128 with SHA. So that's changes over there. So that's all about the Cipher Suite. Again, here the same way the master key is generated, master secret we call it, but here the changes is we can use the pseudo random numbers. PRF or pseudo random generation. If you remember in module 3, if I'm not wrong, or module 4, there was section on pseudo random numbers generation. So the same is used over here, but we don't need that much detail. It's just that we need how it is generated. So you can see the generation of pre-master secret is exactly same as SSL, so nothing new. And key expansion also is done in the same way. Alert protocol is also in the same manner. So you can see the similar kind of alert protocol you can see observe. Okay. So certificate has expired, certificate unknown. The certificate, the indexes will change, the orders will change, something like that. Okay. Nothing that different. So handshake is done with respect to the certificate verification. You can see verify the message, handshake messages using MD5 or SHA1. And then we have created a hash function to it. Again, this you can avoid going forward. This one. This is how it is done, which is not required at all. Record protocol. Now we come to the next second part of it, our discussion of module 7, which is a firewall. Again, all of you must be knowing it. A firewall is a network that provides securities, that monitors the network data traffic. All right. In that, few examples you require, and that is we call it the. I guess how does firewall work? Everyone knows it, but still, like for example, we have an IP address. IP address can be considered as the address of an house. Okay, and the port numbers can be considered as the room numbers. Just an example you can see over there. Now, as we know, only trusted people are allowed to enter the house. So the source address and the destination address should match, and they will try to do that. And only specific, even amongst those people, only specific people will be allowed to come into the rooms also. So those who know. So that's where the filtered person will come. This filtering will be done by the firewall itself. Now, this can be done using different techniques, as we all know. So these are the different sets of firewalls which are existing. All right. Again, just the definition level is enough for illustrations and all. Like for example, suppose a question comes in: how does firewall helps in securing your network? You just explain the few things and give them example of all these elements. And this also, like for example, packet filtering firewalls, these are all obsolete ones, never being used. Mostly the one that is used nowadays is this 4, 5. Okay, so there are hardware firewalls, software firewalls, cloud-based firewalls, proxy firewalls. Those are actually more relevant for us. But still, as we have to discuss all the basic things also. So packet filtering firewall is basically the starting of the firewall where the input and the output of the firewall, you can see the perform simple check of the data packets coming through the router. It will check about the original IP address and the destination IP address. If those two matches, it will allow the packets to come in. It will not inspect the packet at all. And that's the problem, because it will, although it is very resource intensive, it is not a very resource intensive, but the packet is, as it's not traced, naturally it is not immune to the threats by any viruses or any other intruders for the packet. So that's why it is not of very good of use. Same goes with circuit level gateway also, which again is same thing. If a packet is held malware, the right TCP handshake has made. Okay, the handshaking technique is correct, but the packet contains some intruding elements. Okay, and that they will allow. If the handshake, they will only check the handshake. They will not go into the deep of the inspect the packet itself. So that's the problem with this one. Again, this is very low from the resource point of view. It is very low. But the thing is, the very purpose of firewall of filtering the noise or the attacks is not prevented over here. And that is where the proxy firewall comes in, which is a very unique and a very high level firewall, I would say, and it's being used regularly. Where it happens is that it will act as a kind of shield. It will act as a proxy firewall. You can see it is directly letting traffic connect directly. The proxy firewall first establishes the connection to the source of the traffic, and it will behave as a server or the client. Okay, and it will check for the packet. It will go in deep on in the packet, inside the packet, and it will inspect about whether the packet is faulty or not. It will check about the headers. It will check about the IP destination address, the certificates, all the details of the SSL, what is being sent to it. It will check everything. If everything is correct, then only it will pass it on. So that's why you can see once the check is complete, the packet is approved to connect to the destination and the proxy signs it off. So it is basically it's like a shield between the layers so that it locks all the information, like the threads coming in. So that sounds, but the problem is that it becomes slow down. It slow down the process. So in terms of the resource intensive process, it is because it will slow down, because it will take a time to filter out the information. So that's where it will take a lot of time. Then we have the next generation firewall. As you can see, there is no such specific firewall which is existing. We cannot claim as such, but there are different intrusion techniques which are developed, different algorithms which are developed applicable to MAC protocol in different application layer also. So there is no category as such, but there are different set of algorithms which tries to act as a firewall to prevent the attacks. In that, two things which I think you should also know. One of them is called as the software firewalls. So software firewall includes any type of firewall that is installed on a local device that rather than a separate piece of hardware. So this is very common to all of our systems. We also use it for that matter. So these are some of the examples which are there. So you can see at the bottom some of the examples of software firewalls. Big benefit of software firewall is that it's highly useful for creating defense in depth by isolating individual network endpoint from another. Okay. Even in all our systems, we have some kind of an antivirus also. That antivirus along with the firewall usually will have to, in our systems, like we have to negate the firewall, and since we have a antivirus itself installed, so that comes in with respect to creating the same set of buffering or filtering with respect to the intruding data, piracy and all. So, and the other one is a hardware firewall. I don't know how many of you know it or not. There are some hardware device which act as a firewall as well. So hardware firewalls uses the physical appliances that acts as a manner. Usually for the servers, the huge servers that we have, you will actually have some kind of a very hardware firewalls. Software firewall doesn't work in those cases. The major weakness of hardware-based firewall is, however, that it's often easy to insiders to attack or bypass them. So that's the problem. Since it's a hardware, so you can manipulate it in that way. So that is one thing to understand. Cloud firewall is basically the AWS firewall or the Cloudflare Magic Firewall, which are like cloud-based solution. Primarily important, this one is for the IoT devices. Okay, for that we are using this cloud-based firewall mostly. Now that IoT reminds me that we have the last part of our 7th module, which is the web security. Again, very important. Please make a note of this. Web security. So usually, again, very common thing which we come across web security when we are visiting a website or something like that. So how the technologies we use to avoid maintaining the security standards. So these are the different things. So some popular technical solutions are testing, building and preventing the threats. Okay, some of these tools are given. Okay. Now we come to software security again. Software security is any type of software that secures and protects a computer network and all. Okay, very similar to antivirus. You can see the end user computing environment, antivirus, anti-spam software is the most commonly used. So that's basically for the web security part. As we all know, we are very familiar to it. So please make a note of it. IoT threats, as I was telling you, it's very vulnerable to security. People are still working on finding a right solution for IoT devices because it's open to environments. And as you know, for different cases IoT, the sensors are being used for the IoTs, and the sensor will catch hold of the data which is being examined. Like it is very similar, which is mimicking as a data that the sensor will detect that yes, this is the correct data. But ideally, that may be a spoof or that can be a intruding data which goes into the system and it will corrupt the whole system at all. So people are still working, trying to find out that what can be a possible. For example, the projects that you people might have performed in IoT, they don't have any security for that matter, right? This is open to air. Also, the data that you are dealing with in case of IoT services, how the data can be provided with the security, because that fundamentally violates the rule that the security service that it provides, that whatever you are gathering the information from outside, you should keep it secret to the server. There must not be any obligations of revealing the data. But that never happens in IoT. So that's the problem you can see. Since IoT-enabled devices are used and operated by humans, an intruder may try to gain unauthorized access to the service. And that happens to be one of the very common problems that comes in. By gaining the access to wireless IoT devices, the intruder may get hold of the confidential information as well as recalibrate it, change it in performing something mischievous act. So those are the threats for IoT. A vulnerability, you can observe that this is also another problem, that in case of vulnerability, some of the cases what has been reported for the IoT devices, as I said, they are open to environment. Suppose there is an earthquake or suppose a landslide or something like that, those devices might get damaged. Now that itself is a problem, which in network might not happen, but usually for IoT threats, that is one of the vulnerability. You can see the next slide, I think it's there. I think it's there somewhere here. Yeah. So the natural calamities are earthquake, hurricane, floods, and all those things are severe damaging to IoT devices. So what my observation is, so this is human attacks, brute force. This is again, already we have discussed, in fact, brute force attack, I guess, all of you remember in second module itself, we have discussed that when forcefully we try all the other combinations for cracking the data. So same is here. Here the intruder will make an attempt to guess user's password with the help of automated softwares, which makes several attempts unless it gets the right password to grant it. Then we have tracking, where IoT devices can be tracked quite easily. So anyone, if suppose someone is intruding on you, like for example, mobile phone also is vulnerable for that matter. Anyone can track based on if suppose someone wants to intrude on you, they can listen to what you are supposed to call or someone making. Everywhere there is a data log that is maintained. So that's the beauty of it, because it is in a way we are keeping it secure, but in another say, you can say that we are vulnerable to attack. Everything is recorded at some point. Somewhere a digital signature or map is there. Right? So that is basically what is discussed over here. So in summary, we can have that in this particular module, the 7th module, we primarily have briefly discussed about the network security threats aspect, because up to module 6, we have discussed about all the technicalities dealing with the network security. In the first 4 modules, we have discussed about the cryptographic solution itself. So 5, 6 primarily dealt with network security, key exchange, and all those stuff. And here we are trying to find out some of the threats which are looming large, mostly for the network connection. Right? So that concludes our syllabus for cryptography.